right, so now we're going to go ahead and work with and look at a graph of a quadratic function where we have a leading coefficient of the quadratic term that is not 1. So the parent function y equal to x squared, this parent function does have a leading coefficient, right? And the leading coefficient in here is 1, right in the front, all right, but we want to see what happens if if there are different numbers in front. What happens to the graph? All right, we're going to use Desmos and we see what happens. So let's go to Desmos and open up a Desmos account and a Desmos page, punch in the original parent function y equal to x squared, and now we're going to go and play around with what happens if we randomly choose. Let's start choosing some integral values or integers. So let's start with 2. Okay, so we're going to put 2x squared. All right, so what is happening with the value when we put 2 in front? Okay, does the vertex of the original graph changed? No, it's still 0, 0. That didn't change. But the interesting part of this graph is that notice that as you go through the table of values, notice that what is happening, the x values stays the same, but the y values for any given x value. So look at this coordinate right here where it's 1, 1. Okay, we are right in this coordinate 1, 1. It's actually supposed to be 1, 1 right there. All right, so we have 1, 1 in here, but when x is 1, look at what happens to the black graph. Up here 2. Okay, so that is happening when x is now the same. All right, when x is still 1 but the y value is now 2. Okay, and that is true for all the y values of the 2x squared based on the original. Okay, if you compare it to the y equal to x squared, all y values doubled. Okay, so let's see what happens if we do y equals 3x squared. And this is the bolded red graph. All right, so again, look, this is 1, 1. If I can get that exactly the same, 1, 1, almost, yes. All right, so we have 1, 1 in here, which is right at that part, but the new graph will have 1 for x and goes all the way, and that is there, which is 3. It is 3 right there. All right, it's tripled. The y values have been tripled. We call that a vertical expansion. All right, that's what is happening. The graph is getting skinnier. All right, the pattern that you see is an interesting pattern. All right, so we're gonna talk about that pattern based on the coefficient of what is happening with a. So, and if a is 2 or 3 or 4 or 5, notice that what is happening is that the graph just gets skinnier and skinnier and skinnier. All right, so if I punch in y equals 5x squared, now you know what's going to happen. It's basically getting skinnier more. It shoots up faster. The y value now, it's basically 5 times the original y value of y equal to x squared. Great. So that's the first thing that we do know. So let's write that in the note. Okay, here it is. If a is greater than 1, the vertical expansion happens, and usually that vertical expansion increases the y value by that factor a. Okay, as long as it's a greater than 1. Okay, could be 1.5 times even. That doesn't matter. And another way of remembering it is that the graph becomes narrow. Okay, skinnier, narrow, however you want to remember it, but that's what happens. So now let's look at what happens when a is between 0 and 1. All right, so let's go to the graph. All right, now let's look at, I'm going to delete these, and in this case now we have the original graph, but this time I'm just going to put in a fraction in front. 1/2 x squared. Ah, look what happens. All right, let's do a quarter. 0.25 of x squared. What do you think is going to happen now? It opens up. So the graph opens up. The value of y, basically, it becomes the multiple of that a. So basically, it's now the value of y becomes smaller by that factor. Simple as that. You can just see it. And let's go back to the graph. If the original graph was, let's compare the x squared and the quarter x squared. The vertex does not change. Okay, the vertex stays the same because we're not adding any p or q value here. So now that we got the x squared is there. If we have 1, 1, now the same x value of 1 is giving you this value, which is 0.25 for y. Okay, so x is 1, y is a quarter. So the value of y is been basically compressed. Okay, we call it a vertical compression, or compressed by that factor. So let's go back to the notes. So what happened is that in here we get vertical compression by a factor, okay, or by factor of whatever that a is. All right, basically what it means is that the y values, the graph gets wider, okay, and the y value decreases by a factor. Okay, simple as that. All right, and the last case, so this is case 1, that's case 2. The last case 3 is actually on its own. What happens if a is negative? All right, so let's deal with that. Let's go to the Desmos. This time is very simple, and let's start up with y equal x squared, and then instead of x squared we have minus x squared. What do you think is going to happen? It just flips. We call it a vertical reflection. All right, vertical reflection, or reflection over the x-axis, and it does happen. That's all it does. Doesn't matter what the number in front is. So if I put in y equals to minus 2, actually it's to 3, minus 3x squared, same thing. It just flips, and then the 3 takes effect, which is the vertical expansion. But it is that negative in front is the only thing that causes the vertical reflection. Okay, that's the only thing that it happens. All right, let's go to the notes and put that in the notes. All right, if a is negative, by the way, another way of writing it is a less than 0. Okay, then what will happen is that a reflection over the x-axis, all right, or upside down graph, whatever, however you want to put it, that's okay, but that's what will happen. All right, and that is it for this section.